All right, number 2. The density of an aqueous solution containing 25% ethanol by mass is 0.950 grams per milliliter. We got calculate the molality, calculate the molarity, and then what volume of the solution contain that. All right, so we have a percent mass and a density. Now, my recommendation, the percent mass is 20, oh, that's a highlighter, sorry guys, is 25.0 grams of C2H5OH per 100 grams of solution. And the density is 0.950 grams of solution per 1 milliliter of solution. I do it that way. I like that. All right, so now we got to calculate the molality. All right. So if we know that I have 25 grams of ethanol, what else is in the solution? Water. So this would also be the same thing as 25, no, let's use purple, sorry. 25.0 grams of C2H5OH plus 75 grams H2O to get to our 100 grams. So I think we can do the molality kind of like we did number 1. We can do 25.0 grams of C2H5OH and 75 grams H2O. And if we do this, we know carbon is 12.01, and you have 2 of those. So 12.01 times 2 plus you have 6 hydrogens. So you have 1.01 times 6 plus 116 for oxygen. And you get 4608. C2H5OH is 1 mole. And then we know that 100 grams of water, 1 mole of water. So if we do this, I would have my 25 times 1,000, divide 75, divide 46.08, 7.23 is what I'm getting. And so that would be my answer to A. If we do B, molarity. All right. So now I'm going to start with, so that's A. B, I'm just going to start with the density of 25.0 grams of C2H5OH per 100 grams of solution. And we got the same thing coming down here, right? We have 46.08 grams of ethanol is 1 mole. And now I'm going to use the density. We know that there are 0.950 grams of solution per 1 milliliter of solution. And then we know 1,000 milliliters of solution is 1 liter. So now it looks like I got grams per liter. Or I'm sorry, moles per liter. So let's try that. by 25 times 0.95 times your 1,000 divided by your 100 divided by our 4608. So I get 5.154, so 5.15 C2H5OH. Oh, this one. So there's my answer to B. Now C, finally. Volume is 0.275 moles. All right. Well, let's see. I would do our molarity, right? Because molarity times volume, 0.275 moles of C2H5OH. And our molarity of 5.15 moles of C2H5OH is 1. We want 1 liter equals. Now I need to point something out that I did. That needs to be a capital M here. Sorry about that. Fix that. All right, so if we do this math, I got 0.275 divided by our 5.15. Nope, let's try that again. I got 0.0, so 0.053398, and it keeps going. And I have 3 sig figs, so I would say that's 0.0534 liters, or 53.4 milliliters. Depending on the units they would want. All right, so that's number 2.